Everyone thinks the only extra cost of Dynamics Copilot is the subscription fee.
The real kicker is the regional latency, egress, and mandatory localized model charges that act like a hidden tax.
So those latency milliseconds and gigabyte fees actually add up across EU, APAC, and LATAM.
Exactly. Quantify them in a TCO model, and you'll see why on-prem AI can suddenly look cheaper.
Welcome to another deep dive on the CRM Position podcast. We have a highly specific mission for you today.
Yeah, if you are a CRM, AI, or platform architect, you are about to learn how this hidden data residency tax actually operates beneath the surface of Dynamics Copilot.
Right, because we are looking completely past the vendor marketing today. We want to help you build a total cost of ownership calculator, a real TCO model that accurately weighs cloud AI against on-premise alternatives.
And to build an accurate model, we really have to start by looking at the actual physics of the data routing. It's not just about what you pay on a monthly invoice. It's about how the electrons physically travel across the globe.
Which is fascinating because the physics of data routing is precisely where standard enterprise budget forecasts just fall apart.
Oh, completely. Because when you deploy Dynamics Copilot, you're not just running some local software application. You are executing complex, large language model inference calls.
Right.
And every single one of those calls has to physically travel to a regional endpoint. And in the world of network architecture, distance equals time.
So let's break down what that time actually looks like in practice.
Sure. So if you are routing your traffic through an endpoint in EUS2, that round trip is adding roughly 30 to 70 milliseconds to the transaction.
Okay, 30 to 70, that's EU. But what if we're further out?
Well, let's say you are operating a massive customer service center out of APAC Southeast. That exact same API call now consumes 120 to 180 milliseconds.
Wow, so it basically triples.
Exactly. And under Microsoft's tier-based Azure OpenAI pricing, this added latency translates directly into an incremental transaction cost. It comes out to about 4 ten-thousandths of a dollar for every 1,000 API calls.
4 ten-thousandths of a dollar. Honestly, if I'm a CFO looking at that number, I'm immediately tuning it out. It sounds completely trivial.
Right. In isolation, it absolutely is. But you have to think about the scale of a high-volume customer experience environment.
Ah, the volume.
Right. An automated CX routing engine is making millions of inference calls a day. So that baseline latency is constantly ticking the meter. And latency is really just the time factor. We also have to calculate the physical weight of the data moving across those distances.
The egress cost.
Exactly, your egress cost.
Yeah.
Moving data from the European Union to the United States costs 9 cents per gigabyte under standard Azure rates. But if you hit premium regions...
Weight goes up.
Oh, yeah, that rate jumps to 12 cents per gigabyte.
It reminds me of the old cellular roaming charges for enterprise data.
Yes, that is a perfect way to look at it.
Because it's a completely invisible mechanic, right? The data moves, the service works perfectly, your end users are totally happy, and the roaming charge is entirely hidden until the bill arrives at the end of the month.
It's exactly like that. And here is how that roaming charge scales up in reality. A typical CX workload streams about 2 gigabytes of interaction logs for every 1,000 sessions.
Okay.
So that adds an extra 24 cents to the cost of each 1,000-session batch. And we are talking about continuous log streaming here.
It never stops.
Right, it never stops. When you have a live CX operation running 24/7, that continuous egress component can suddenly dominate the entire cloud-only TCO.
Okay, so the physical data movement and the time it takes are these hidden operational costs. But the official documentation leaves out some major structural costs too, doesn't it? Because didn't Microsoft recently change the baseline requirements for these regional deployments?
They did, yeah. Microsoft now mandates a separate localized model instance for every sovereign region.
Meaning what, exactly?
Meaning you need separate dedicated instances for the EU, APAC, and LATAM. And this mandate introduces an additional $3 per user per month on top of the base Dynamics Copilot subscription.
Let's pause on that for a second because I want to make sure I understand the scale here. If I modeled a massive global CX workforce at a $30 per month base license, I'm actually paying $33 a month just for the privilege of an EU-only deployment.
Yes, exactly. It seems like a modest fractional uplift per user, but it scales aggressively across thousands of seats. And the thing is, the localized model mandate is really just the entry fee.
There's more.
Oh yeah. You also have compliance-driven storage to factor in. For example, GDPR obliges your organization to retain those interaction audit logs in region for 12 full months.
Right, the retention rules.
And Azure Blob Storage charges an extra 2 cents per gigabyte month for that retained data. So if your CX organization is logging 500 gigabytes a month, you are paying an additional $12 every single month solely to satisfy regional retention rules.
Okay, let's unpack this for a minute. We have fractional pennies from latency. We've got a $3 licensing uplift per user and an extra $12 a month for regional blob storage.
Correct.
In a vacuum, on a spreadsheet, these numbers still sound incredibly manageable to an enterprise. But we know TCO isn't built in a vacuum. What actually happens when these baseline mechanics interact with real-world enterprise stressors?
Well, that is exactly where the theory falls apart and the real financial damage happens. Let's look at 3 real cases where this underlying mechanism forces enterprise decisions.
Okay, let's hear them.
We'll start with what happens when network physics turn into financial penalties. We can call this the service level agreement latency trap.
A trap because the network speed directly impacts a contract you've signed.
Precisely. Let's say you have an Azure network congestion event. These happen, it's normal. Suddenly, your baseline latency spikes to 250 milliseconds.
Which is huge compared to the 30 we talked about earlier.
Exactly. And because your chatbot response times are tied directly to that inference call, the average response time pushes beyond a strict 2-second SLA that you've signed with a client or even an internal business unit.
Oh, wow. So that physical congestion just triggered a breach of contract.
Yep. We've seen past incidents where this exact scenario triggered up to $50,000 in SLA penalties. You are literally paying a financial penalty because of a temporary fluctuation in Azure's regional network traffic.
The network bottleneck literally becomes a balance sheet liability. That is terrifying for an architect who thought they just deployed a standard Copilot instance.
It really is.
Let's move to the second case, burst mode data transfers. I like to call this the egress surge surprise. Imagine a marketing campaign that relies on heavy image analysis.
Okay, heavy data load.
Right. And through a simple configuration error, the requests generated by this campaign are inadvertently routed to a US-based model instead of the local one. In a single week, that campaign generates 5 terabytes of cross-border traffic.
And that 5 terabyte burst results in a surprise bill of $450,000.
Wait. I have to stop you there and push back. 450 grand. How does a standard enterprise-grade TCO calculator completely miss a 5 terabyte burst? We have senior architects building these financial models. They aren't just guessing.
They miss it because standard TCO calculators are entirely static.
What do you mean?
I mean, they model baseline steady-state operations.
Meh.
They do not model dynamic campaign-driven routing, where a single wrong endpoint configuration suddenly pulls high-density data-like image analysis across a sovereign border.
Ah, I see.
Yeah, a static calculator assumes perfect architectural compliance. It assumes the image request will always hit the local instance. When the reality of dynamic routing breaks that assumption, the egress multiplier kicks in instantly.
So the model assumes perfection, but the reality is a massive, highly expensive error. And that sets up the third case perfectly, actually, the compliance misconfiguration. Because this isn't just about egress fees anymore, is it? This is about international sovereignty laws.
Right, the legal side.
So let's say a LATAM deployment is mistakenly pointed to an EU model. The data is routed perfectly, the application works, there's no visible latency issue for the end user.
But it directly violates data sovereignty laws.
Yes. We have seen that specific architectural error attract regulator fines in the order of 150,000 euros.
Because regulators do not care if your latency was optimized or if the AI output was highly accurate. They only care that the regional data boundary was crossed without authorization.
Right.
The localized model mandate exists for a reason. Bypassing it, even accidentally through a simple config error like we just talked about, turns an operational metric into a serious legal penalty.
So it's clear that static budgets just fail. They fail to capture burst risks, they fail to anticipate SLA penalties from latency spikes, and they absolutely fail to account for 6-figure compliance fines. To accurately compare cloud AI against on-premise alternatives, we need a dynamic operational framework. So let's break down a practical 4-step framework to actually calculate this. Step 1. You must quantify your dynamic cloud variables.
Right. You have to calculate your regional latency baselines and your cross-border egress rates based on your specific traffic patterns. And you have to factor in regional volatility, too.
Like what?
Well, for example, in APAC, usage-based egress fees can swing month-to-month CS budgets by plus or minus 15% during peak promotional campaigns. You have to build that variance into your model.
Okay, so once you have those dynamic variables, you can start comparing your options. Let's talk about step 2, which is modeling the hardware versus labor arbitrage for on-premise alternatives.
Yeah, when you are looking to mitigate these unpredictable cloud costs, you might consider a reserved instance to lower the cloud price tag. A one-year reserved instance for Azure OpenAI cuts your compute pricing by up to 35%.
Mm-hmm.
Now, in LATAM, where those baseline egress fees are lower, that 35% discount actually shifts the break-even horizon for cloud versus on-prem LLM hardware.
By how much?
It drops it from 18 months down to just 9 months.
Hang on, I'm having a bit of an aha moment here. If the break-even shifts that drastically based on the region, then choosing on-prem isn't just a hardware play, it's a labor arbitrage play.
It is entirely a labor arbitrage play. If you deploy on-premise to avoid these cross-border egress fees entirely, well, you now own the hardware.
Right.
And hardware requires specialized labor to maintain it. Think about an IT director trying to staff this. In LATAM, the average monthly cost of a GPU maintenance engineer is about $1,200.
Okay, that's fairly reasonable.
But if you try to replicate that exact same engineering role in the EU, say, hiring in Paris or Berlin, that cost doubles to roughly $2,400 a month. Any true TCO model has to balance the cost of cloud egress against the cost of regional engineering labor to reveal the true residency tax. You are literally trading cloud physics for human payroll.
That makes step 3 incredibly vital then, capturing the hidden on-prem capital expenses. Because if you are going the hardware route to dodge the egress tax, you cannot ignore the physical reality of the servers.
You really can't.
Mandatory GPU cooling and facility power upgrades are frequently omitted from initial budget models. Skipping those physical infrastructure requirements can underreport your capital expenses by $200,000 over a 3-year horizon.
Yeah, people just forget about the power bill and the HVAC.
Right.
And that leads to step 4. Executing the RCI protocol.
Okay, RCI.
Right.
Responsible, accountable, consulted, and informed.
Right. And I know this isn't just an exercise in throwing management acronyms around. It is about building a defensive perimeter against that $450,000 surprise bill we talked about earlier.
You need clear cross-departmental accountability to navigate this physics problem. How does that map out in practice?
Let's break down the roles. The CX architecture lead is responsible for defining those latency baselines.
Okay.
The cloud cost manager tracks the dynamic egress rates and reports them directly to the CFO.
Got it.
Then procurement managers, who operate under the CFO's accountability, are the ones buying the regional add-ons and consulting with data sovereignty experts.
So they handle the localized licenses.
Exactly. Finance analysts own the actual TCO calculator. The data protection officer validates compliance with regulations like GDPR in Europe or the PDPA, the Personal Data Protection Act in APAC regions.
And the executives.
Finally, the quarterly AI spend reviews belong to the Finance Steering Committee.
So every single one of these variables, from the $1,200 LATAM engineer to the APAC baseline latency, has a specific owner.
Because if a configuration error routes 5 terabytes to the US and triggers a massive egress bill, you cannot have the cloud cost manager pointing at the CX architecture lead, who then points at procurement. The RECI protocol maps the physical movement of the data directly to the accountability of the organizational chart.
That makes total sense. Now, if you strictly follow this 4-step framework, you solve the TCO math. But doing so fundamentally alters how your global teams operate and build.
It really does.
The implications of this data residency tax ripple out and change your architecture, your team, and your entire roadmap. Let's start with the architecture itself.
Okay, so the requirement for localized model instances effectively eliminates the possibility of a single-tenant global model. You are now managing highly fragmented operations.
Right.
Because the models are localized, you cannot uniformly prompt tune across geographies.
Wait, why not? If I have a great prompt that drives incredible customer satisfaction in Berlin, why can't I just deploy it to my team in Singapore?
Because of context drift and strict sovereignty rules. A prompt that is highly optimized for the EU instance might rely on data structures or localized model versions that simply do not exist in the APAC instance.
Oh, I see.
Yeah, you completely lose the economy of scale that usually comes with a massive global cloud deployment.
And that fragmented operation creates a massive hidden training drag on the organization. Your CX analysts in LATAM now require highly specific, region-aware prompt design training.
They literally have to be trained on how to write prompts that do not accidentally request data that forces a cross-border call.
To avoid triggering those egress fees. And that hidden training requirement averages $4,000 per analyst.
It's a huge hidden cost, and the fragmentation hits procurement just as hard. You are negotiating separate contracts for Copilot licenses, Azure OpenAI Compute, and the regional add-ons.
Which slows everything down.
Right, that fragmented contract structure adds roughly 2 weeks to the legal review cycle per region. You are losing agility at every single step.
I have to ask about broader corporate reporting too, because we're talking about IT and finance, but does this localized routing impact anything outside of those budgets?
Actually, it directly impacts environmental, social, and governance, or ESG reporting.
Wait, really? ESG?
Oh, absolutely. Specifically, your Scope 3 emissions. Scope 3 covers the indirect emissions that happen in your value chain.
Okay, because you don't own the Azure servers, Microsoft does, but your architecture is generating the traffic.
Precisely. Increased network traffic for cross-region calls directly raises your Scope 3 carbon emissions. To put a hard number on it, an extra 10 terabytes of EU to US cross-border traffic per month adds roughly 0.5 tons of CO2 equivalent.
That's a hard figure that must be disclosed in your corporate sustainability reports.
Yep. Your data routing architecture is now directly impacting your company's ESG footprint.
This brings us to a highly controversial perspective that is starting to emerge in the field. Because what if an enterprise has a stretched CX budget and they look at the $4,000 per analyst for training, the 2-week legal delays, the ESG hits, and the fragmented prompt tuning?
And they just say no.
Right, they just say no. What if they simply ignore the data residency tax entirely and host a single global Copilot instance in the absolute cheapest Azure region?
Well, it is a radical approach. But proponents of this centralized model argue that the incremental latency and the compliance risks are actually marginal when compared to the strategic loss of agility.
Okay, so agility is the main driver.
Exactly. For them, multiple regional deployments mean delayed rollouts, heavily fragmented training, and drastically slowed innovation. They contend that the organizational cost of losing that operational agility vastly outweighs the modest financial savings of avoiding the data residency tax.
Now, we're outlining this dilemma impartially because it is a very real strategic debate happening right now in the market. Do you strictly localize and accept the fragmented operational drag? Or do you centralize, prioritize agility, and accept the compliance and latency risks?
It's a tough call.
We aren't taking a side here, but it is a strategic crossroads you must acknowledge. Whether you strictly localize or controversially centralize, hoping for the best is simply not an architectural strategy. You need immediate, concrete steps.
Absolutely. The hidden data residency tax is going to be paid one way or another, either in egress fees and compliance storage, or in delayed rollouts and SLA penalties. You have to be proactive.
Let's get into your execution plan for this week then. We have 3 concrete actions you need to take right now to get ahead of this. First, audit your current Copilot routing to identify any accidental cross-border egress loops.
Good call.
Pay particular attention to routing between LATAM and the EU or US. You want to find that misconfigured image analysis request before it generates a 5 terabyte surprise bill. Second, review your finance team's TCO model. You need to ensure they aren't double counting the base Dynamics Copilot license and the regional add-on.
Yeah, that double counting issue is a very common error. It ends up inflating AI budget proposals by 12%, which often causes senior leadership to reject the spend outright.
Right, kills the project before it starts. And third, assess your physical infrastructure. If you're leaning toward an on-premise deployment to leverage that labor arbitrage we discussed, verify that the $200,000 facility cooling and power upgrade is actually in your internal capital expense forecasts.
Do not let the hardware cooling requirements become your own personal hidden tax.
Exactly. As you work through those 3 actions, we want to leave you with one critical question to reflect on. If your team's prompt engineering suddenly dictates your network egress costs, are you currently training your CX analysts to think like network architects?
That's the real question.
To truly understand how CRM and AI platforms actually work under the hood, you need to be subscribed to the CRM Position podcast. We don't just read the vendor marketing to you. We break down the complex architectural shifts and the real operational mechanics that drive your business.
Subscribing is the essential tool to stay ahead of the actual physics of platform deployment, entirely without the hype. Subscribing ensures you are building strategies on operational reality, not marketing narratives. We'll see you on the next deep dive.
At the end of the day, you don't want to be the architect opening up the enterprise equivalent of a massive, invisible cellular roaming bill. The data is always moving. You just need to make sure you know exactly what it costs when it crosses the border.